Welcome to another episode of PNW Weather 101. I'm meteorologist Tanis Leach, and today I will be talking about the quasi-biannual oscillation, something that does not tend to get talked about as often as the more well-known ENSO phases, or El Nino slash La Nina, or the Pacific Decadal Oscillation. Yet it is critically important to know if you want to predict what's going to be happening in any given winter here, as there are some significant correlations. Is the snowman correct? Is a westerly phase really better for snow? We'll find out in this video. So first off, what is the QBO? QBO is on average a 27 to 29 month cycle measuring winds in the stratosphere between about 10 millibars and 100 millibars pressure level. It's divided into a westerly and an easterly phase. It's often considered the second most reliable atmospheric prediction, only after the seasons themselves. Winds are generally measured near equatorial sites, and this has to do with the polar vortex. QBO values near 1980, you could see how reliable the QBO is. Anything in gray here is the westerly phase of the QBO, while in white is the easterly phase of the QBO. If you look a little bit closer, you can notice that the easterly phase of the QBO tends to be a little bit stronger overall, but oftentimes doesn't last as long as the westerly phase does. There's really only two interruptions overall to the cycle. The first was in 2015 to 2016, which is really the only true interruption, where it was just a prolonged westerly phase with it kind of trying to get into the easterly phase, but the entire atmospheric column did not flip into the easterly phase and just stayed westerly. In 2019 to 2020, it did try to go easterly, but it didn't get that strong into the easterly phase. I'm not sure whether to call this a true interruption in the cycle or just a super weak easterly phase, because it did flip easterly through the entire atmospheric column. So that one I would put an asterisk on in terms of, oh, it failed to perform normally. Yeah, but it did flip easterly technically. So see what happens in the coming years to see if that ends up continuing or if it ends up keeping the 27 to 29 month cycle. So, as I mentioned earlier about the polar vortex, so what the polar vortex is all essentially it's all the cold air that is trapped up near the Arctic. A stronger polar vortex means that you have a stronger polar jet stream that is more stable and that keeps the cold air trapped up here. So a QBO that is westerly means that these winds are going in the same direction as the winds with the polar vortex. So that signifies that the polar vortex can actually maintain its strength with this. But on an easterly phase, the equatorial winds are going in the opposite direction in the stratosphere compared to the polar vortex winds. So that is also why the winds are generally measured near the equator, because the polar vortex are generally blowing from west to east 95% of the time, excluding in major sudden stratospheric warming events, which we'll get into later. This can promote a weaker polar vortex as a result and can disrupt the polar vortex. So on the left was the stable polar vortex scenario that I discussed. That can bring a lot of systems back to back to back in the Pacific Northwest, while a disrupted polar vortex produces a more wavy jet stream as cold air surges south into the more temperate latitudes. There's no real correlation to find where this will go just from a sun stratospheric warming event happening. It's a lot like a game of Plinko. You know it's going to go south, you just don't know where it's going to go. That also means that ridges can form, which can produce warmer than normal temperatures under these ridges. Though in the heart of winter for the Willamette Valley and the Puget Sound, this can create an aversion due to the weak sun angle, and the valleys stay trapped in cold air and oftentimes fog the entire day, while the mountains end up being 60 degrees and sunny. Now, the next slide I'm going to show is the sun stratospheric warming event. I would like a little bit of background before I jump into that. So, the sun stratospheric warming event is when the temperatures in the stratosphere suddenly warm, as the name suggests. Also, the polar vortex winds tend to slow down significantly, if not reverse a little bit. And that can promote a disrupted polar vortex. In fact, a major sun stratospheric warming event is a near guarantee of a disrupted polar vortex like pattern. So, this is how the QBO affects sun stratospheric warming. So the QBO can have a big effect on sudden stratospheric warming events, and this also combines with the ENSO state that we're in for any particular year. So on the top here is the westerly phase of the QBO, and on the bottom here is the easterly phase of the QBO. And this is an average of the wintertime wind speeds. On the left here is La Nina conditions, and on the right here is El Nino conditions. So, starting off with the westerly QBO here, with the La Nina, less than half of years had a sudden stratospheric warming event, but for an easterly QBO with a La Nina, 92% of years had a sudden stratospheric warming event. For a westerly QBO and El Nino, 62% of years had a sudden stratospheric warming event, though in Eastern QBO, it was a little bit higher, but not as significant as La Nina, with about 77% of years having a sudden stratospheric warming event. This was the only big correlation I found between ENSO and the QBO, but it is a pretty important one in terms of predicting how likely a sudden stratospheric warming event is going to be in the upcoming winter. For more generalized easterly versus westerly anomalies, I'll start on the left here. This is the winds taken at 200 millibars, and that doesn't matter as much for our climate here in the Pacific Northwest. So let's look at the surface temperatures. So this is an AMS study. I'll link it in the description below. This is using the studies model. If you want to dive more into it, this also has a couple other data sets that you can look at as well. The little divot here that shows a little bit thicker black than usual, that is the Puget Sound. So that is right on the boundary of above normal conditions in an easterly QBO compared to anywhere south where there's not really statistically enough evidence to say, hey, it's warmer than normal or hey, it's colder than normal, like you see out in the eastern part of the United States. For snow depth, there is about a 10 centimeter below normal snow depth. This is actually the darkest green that I am seeing on the map in an easterly QBO. In terms of some generalized effects, the westerly phase produces heightened odds of below normal temperatures and slightly above normal precipitation. It does also increase UV radiation during solar minimums. The easterly phase is generally the opposite base state. It's heightened odds of above normal temperatures and slightly below normal precipitation. It increases UV radiation during solar maximums. Because of the increased odds of a sun stratospheric warming event, though, this can get thrown off with a random Arctic blast or two, though Arctic blasts are still plentiful with a westerly phase as well as we go on to our correlations here. So first off, there is a lot of correlations with snow, a lot specifically with PDX. You can thank the gorge for a lot of these, which tells me that the QBO does affect patterns through the Columbia River Gorge specifically with this. I didn't find a strong correlations elsewhere, so that's also evidence to believe the gorge and the QBO are mixed at least a little bit here. So first off here, all above median snowfall years that occurred with an El Nino happened during westerly QBO at the 30 millibar level on January 1st. As a disclaimer, this did not guarantee snowfall if these two patterns lined up. The hit rate was 9 out of 13 El Ninos in this case, or about 77%. All but one 10-inch plus seasons happened with a westerly QBO at the 30 millibar level on January 1st. With Eugene, I actually noticed the correlation was non-existent. It was about 50-50 westerly versus easterly. The exception was 2003 to 2004, and it was about 10 meters per second easterly and falling, as by January 15th, it was westerly at the 30 millibar level. As a note with both of these, I'm using the 30 millibar level because that's a simple place I can look at that was the strongest with both of these correlations, number one and number two. For all of these correlations where I can look at a specific date, I looked at January 1st. So there was a consistent date that was about halfway through the wintertime period for the western United States. Also, as a sidebar, median snowfall is about 3 inches at PDX compared to the long term average of 4.3 inches. Lastly, all ENSO-neutral snowless winters occurred with a westerly QBO at the 20 millibar level on January 1st. This one had a little bit of a different correlation using the 20 instead of the 30 millibar level, but it is completely different than having a firm ENSO state, which tells me that ENSO-neutral is being, in my opinion, a little bit more chaotic than an El Nino or La Nina ends up being true in this case. So looking at some other correlations here, first off, all years that got into the single digits of PDX had a QBO value on January 1st at the 30 millibar level be 10 meters per second or lower. So 10 meters per second does not happen often with the QBO. Generally, I would say about 85% of the time, just quick estimate looking at the chart there at the 30 millibar level was at 10 meters per second or higher. So the fact that all of it pretty much happened on about 15 to 20% of years, that's a pretty significant correlation. Though I will say the sample size is pretty low. I think it's about 6, just going off the top of my head here. All the snowiest years at Timberline, top 5, were all westerly QBO. And then lastly, this one's just for fun here. I need to do more research to see if this is actually a correlation. The big three Willamette Valley windstorms, the region-wide one, so this is the Columbus Day storm, the Friday the 13th, 1981 storm, and the December 1995 storm, all had an easterly QBO. When I started to look a little bit more broader to the South Valley and the Puget Sound, this did not apply. And the thing is, for windstorms, the setups are generally very similar in terms of what you get out of it compared to a snow setup where it's can be very different in terms of getting the proper snow setup for Portland compared to the proper snow setup for Eugene. Also, one thing to note is, as you saw earlier, the QBO data only goes back to the mid 1950s, so I do not know what the QBO values were in the back-to-back super snowy winters of 48-49 and 49-50. So that is a little bit of a disclaimer on these correlations. And lastly, in summary, yes, the QBO can affect the Northwest climate primarily on the side, though it can affect the base states of the climates very slightly. While the westerly phase is typically a colder and wetter base state, the easterly phase is a little bit more volatile due to more sun stratospheric warming events. The net warming is less than a tenth of a degree Celsius, though, in terms of the average case. The heaviest snow years require a westerly QBO, at least in Portland and up at Mount Hood. So that is it for this video. I hope you all learned something from this. And until next time, please stay safe out there and take care.